पुलों ने सदियों से काम किया है जोड़ने का, कभी संस्कृति को तो कभी लोगों को, कभी संप्रदाय को तो कभी व्यापार को। इसीलिए विकास के कदम और पुलों का नाता है अटूट। भारत का खूबसूरत पूर्वोत्तर क्षेत्र वर्तमान सरकार के प्रयासों से प्रगति के पथ पर है अग्रसर, और अब ये क्षेत्र साक्षी बनने जा रहा है उन्नति के एक और शिखर का। असम में ब्रह्मपुत्र नदी पर डिब्रूगढ़ से 17 किलोमीटर दूर बना है देश का सबसे लंबा रेल सह सड़क पुल बोगीबील। यह ब्रह्मपुत्र नदी पर सबसे ऊंचाई पर है बना, जिसकी कुल लंबाई है 4.94 किलोमीटर और लागत है 5,920 करोड़ रुपए। डबल लाइन ब्रॉड गेज के साथ 3 लेन रोड की विशेषता वाले इस पुल के निर्माण में ब्रह्मपुत्र नदी में हर साल आने वाली बाढ़ का रखा गया है विशेष ध्यान। इसीलिए दोनों छोर पर 9 किलोमीटर और 7 किलोमीटर बांध को ऊपर उठाने और मजबूत बनाने पर दिया गया जोर। यह होगा भारत का एकमात्र ऐसा पुल जो पूरी तरह से स्टील कंक्रीट कंपोजिट गर्डर से है बना। तत्कालीन प्रधानमंत्री स्वर्गीय अटल बिहारी वाजपेयी ने 22 अप्रैल 2002 को की थी इस पुल के कार्य की शुरुआत, लेकिन इसके काम में हो रहा था लगातार विलंब। 2014 के बाद काम में आई अभूतपूर्व गति। जब प्रधानमंत्री नरेंद्र मोदी ने इस पर दिया विशेष ध्यान, अटल जी के समय तरक्की का बोया गया पुल रूपी बीज आज बना है फलदार पौधा। रेल सह सड़क पुल होने के कारण ये जोड़ेगा उत्तर और दक्षिण छोर के 74 किलोमीटर रेल लाइन को भी, साथ ही दक्षिण के NH37 और उत्तर के NH52 को भी ये जोड़ेगा। पुल द्वारा जुड़ेंगे असम और अरुणाचल के साथ ब्रह्मपुत्र नदी के उत्तर और दक्षिण छोर। इससे उत्तरी असम और पूर्वी अरुणाचल प्रदेश के सामाजिक आर्थिक विकास को मिलेगा बल। पूर्वोत्तर की बढ़ेगी रेल कनेक्टिविटी, डिब्रूगढ़ पहुंचना होगा आसान, जिससे गुवाहाटी में कंजेस्शन होगा कम। ये पुल ब्रह्मपुत्र के उत्तरी तट के माध्यम से डिब्रूगढ़ के लिए एक छोटा और सुविधाजनक मार्ग करेगा प्रदान। पुल रेलवे मार्ग द्वारा 705 किलोमीटर और सड़क मार्ग द्वारा 150 किलोमीटर की दूरी कम करते हुए डिब्रूगढ़ से ईटानगर तक प्रदान करेगा सीधा सड़क संपर्क। डिब्रूगढ़ से वाया उत्तर छोर का अंतर वाया रंगिया 170 किलोमीटर होगा कम। साथ ही डिब्रूगढ़ से गुवाहाटी वाया मोरनहाट की दूरी भी होगी 55 किलोमीटर कम। पुल के कारण बनी रहेगी हर मौसम कनेक्टिविटी। माल ढुलाई, यातायात जो पहले होती थी फेरी से, वो अब होगी बहुत आसान। होगी पैसों की बचत। ब्रह्मपुत्र नदी के तटबंध पर रहने वाले लोगों के दोनों छोर पर 16 किलोमीटर का सर्विस रोड बनाएगा यातायात को सरल। पुल देश के पूर्वी कोने तक सेना को और सेना तक सप्लाई पहुंचाना करेगा आसान। राष्ट्रीय सुरक्षा की दृष्टि से है पुल का विशेष महत्व। तभी तो ये पुल बनेगा पूर्वोत्तर भारत की जीवन रेखा। अब रेलवे, नॉर्थ ईस्ट और विकास हैं एक दूसरे के पर्याय। भारत के प्रधानमंत्री नरेंद्र मोदी इस पुल को कर रहे हैं राष्ट्र को समर्पित। जय हिंद।
Now I request Mr. SCG to start with the presentation.
Ladies and gentlemen, a very good afternoon to all of you. At the outset, I'd like to express our sincere thanks and gratitude to the management of NHAI and the organizers of this conference for having given us this opportunity to showcase the construction of Bogibeel Bridge, which has been done by SCC over the mighty river Brahmaputra. Now, as the name signifies, the Brahmaputra, the male river, it is ferocious, it is known for its fury, it is known for the turbulence, it is known for the flood. At the first session, we have seen one devastating video of flood which is caused in the Barak River. But then to say the truth, Brahmaputra is nothing less than 10 times more furious than Barak. The design flood at the location where the Bogibeel Bridge has been constructed is estimated to be about 45,000 cubic. But the question might come that, yes, in the river Ganges in Kolkata, the design flood is somewhere close to 70,000, which has been observed also. Then in what way the Brahmaputra can be considered as more ferocious compared to the Ganges? If you see the hydrograph of this Brahmaputra, particularly at the bridge location, you will find that the rising limb, it lasts hardly for 5 hours, whereas for the Ganges, it lasts for a period of 12 hours. So that indicates the steepness of the rise in the flood. Nonetheless, such lesser time gives very less warning, and the problem is compounded when untimely release of flood is there from upstream our neighboring territory, that is China. Now this bridge, apart from this challenge, it could be completed only with the strong determination and with grit, particularly the untiring and selfless efforts made by the SCC staff, workers and engineers. At this point of time, I would like to place on record the support and cooperation that we have received from all corners, particularly the Indian Railway, in overcoming all technical and other issues to complete the project in a manner it was expected to be completed. This bridge is special attribute in the sense that it's first of its kind in India. It's totally a welded bridge, composite bridge, steel and concrete, and particularly in the area receives a lot of rainfall, and therefore the extent of corrosion is pretty to be severe. So in order to protect the bridge, to ensure the bridge lives for the design lifetime, corrosion protection measures have to be applied. For this special kind of steel with copper bearing have to be employed, apart from other electrical situations. Our program of construction was further compounded due to the shorter scale as reported in the northeastern part of the country for more than 5 months. Increments is a quick period. Secondly, this area was not having proper infrastructure, it was lacking proper communication, and that was another bottleneck for us to achieve the desired progress. So the video has already been shown. This is another video which will showcase the method of construction that was used in this process. After completion of this video, I proceed with the presentation. Regarding the project location, it is located in the district of Dibrugarh in the state Yeah, it's already completed and made operational. It's located in the district of Dibrugarh in Assam, at about 17 kilometers downstream of the town, which is about 440 kilometers downstream of capital city Guwahati. Until then, until construction of this bridge, the Brahmaputra River was bridged at 4 locations. 2 bridges were constructed in Guwahati in the name of Saraigat Setu. The second one was Tejpur Road Bridge, which was constructed by SSC in 1987. Then the uppermost bridge is the Bogibeel Bridge. So out of the 5 bridges that have been constructed on this river, 3 have been constructed by SSC, and I take that pride in saying that SSC has been pioneering in bridging Brahmaputra, particularly in the part of Assam. Regarding the salient features, the project comprised of providing the superstructures comprising of original scope of 34 spans with 125 meter each, along with 2 numbers of apartment spans of 32.6 meter. But then, since the DPR was prepared and the project was constructed, the river, because of its immense erosive potential, the width of the river had increased, requiring revision in the scope. So 34 spans had to be increased to 39 spans, keeping the span length same as 125 meter. The client was Northeast Frontier Railway. The work was awarded to SCC Vienna DSD Consortium at a project cost of 987.196 crores. But because of increase in the span, the revised project cost was estimated to be 1100 crores approximately. The type of contract was an item rate contract. Date of LOI, that is letter of intent, was 23rd of November 2011, with the original completion period of 48 months. But because of increase in the scope of the work, the completion period was extended by another 4 months, that is to 52 months. The overall length of the bridge, originally it was estimated to be 4.315 kilometer, and the revised length is 4.94 kilometer. The span arrangement I have already said. The type of superstructure, it was a composite welded wear and truss girder with road deck at top chord and rail at bottom deck. So this is a bridge of first of its kind in India, that bridge with rail and road has been constructed over Brahmaputra. Then superstructure configuration was 2-tier bridge with 2 BG tracks on the lower deck and 3-lane road on the top deck. The center to center of the truss was 10.6 meter apart. Overall depth of the truss was 12.5 meter. The HFL at the bridge location was 102.92 meter, which is as per requirement of navigation clearance, a vertical gap of 10 meter is to be maintained and a horizontal gap of 100 meter is to be maintained. And we have maintained a vertical gap of 15.7 meter, and in place of 100 meter, the span length was given as 125 meters, so well meeting the navigation requirement. This Bogibeel Bridge project, as I said, this is first time in India, total welded steel truss girder. India's longest rail-cum-road bridge project. First time in India that Eurocode was followed for bridge construction activities. And first time in India, incremental launching was adopted for such a long bridge. And first time in India, bridge inspection trolley has been used for future inspection and maintenance. Now, on the timelines of this project, in the year 1985, the famous Assam Accord was signed between the then Honorable Prime Minister of India, Rajiv Gandhi, and the All Assam Students Union, and the project was approved by the Planning Commission. And in the year 1997, the project was sanctioned and the feasibility studies was undertaken by Government of India, followed by in 2002, the foundation stone was laid by the Honorable Prime Minister Sri Atal Bihari Vajpayee, and the work commenced. So in the year 2007, it was declared as a national project. In the following year, the commencement of substructure started. The substructure work was awarded to Messrs. Gabon India Limited. And in 2009, the southbound work got completed, followed by completion of the northbound work in the year 2010. And in 2012, after award of LOI to SSC, the commencement of superstructure work started, and in the year 2014, the first girder was placed. And all other activities then continued. In the year 2017, completion of all civil works and completion of the entire bridge launching by November 2017. This bridge was inaugurated and handed over, and the service, it was Sri Narendra Modi ji, he had dedicated this bridge to the service of the nation on 25th of December 2018. Since then, the bridge is operational Now regarding the project scope, broadly we can divide it in 5 parts. One is quality management system, then structural steel works, which comprises of fabrication, erection and assembly. And then bridge inspection unit, 2 numbers of bridge inspection units were provided in this. Then civil works, which comprised of providing the top decking and followed by permanent way works like laying the BG tracks, etc. So on the scope of work, preparation of shop and fabrication drawings for fabrication of steel work based on approved drawings, fabrication, erection and launching of span truss, application of corrosion protection system, providing and fixing pot cum PTFE bearings including anti-seismic arrangements. Regarding this anti-seismic arrangement, I must tell you that this falls within the seismic 5 zone of Indian seismological map. Therefore, it calls for the design to sustain a value of nothing less than 7.0 as per Richter Hector scale. And this project has been designed for a Richter Hector scale of 7.2. Then provision of RCC slab, back. Provision of RCC slab for footpaths, curbs, railings, and mastic bituminous asphalt over the road decking, and linking of new BG track, including laying of 60 kg by 52 kg rails, which are low weight rails on H-beam sleepers, distressing of LWR, laying 52 kg switch suspension joint on special H-beam sleepers. Now, quantity of major works basically is a steel bridge. So you may see that bridge involved about 62,400 of supply, fabrication and erection of steel struts, then stringers, pressing and other miscellaneous items accounted for 16,540. So in totality, this is giving about 80,000 of steel material to be handled for the project. Next. Now for part truss, if I consider, you'll see that supply and fabrication of erection of steel truss was 1980 part truss, and cutting of steel plates involvement was 28,935 running meter. Edge preparation involvement was 811 for scalloping, and for beveling it was 12,820. Next. So this is a general arrangement of the truss that was fabricated. And the typical cross section of the bridge, you may see that the bottom width is 11.6 meter and the top height is 12.5 meter. The major equipment which were deployed for fabrication purpose are 2 overhead gantry cranes of 20 ton capacity, deployed at 2 different bays in the fabrication workshop. Quantities were 8 numbers, and 2 numbers of 25 ton gantry cranes were deployed, apart from other machineries like for box making machine, CNC flame cutting machine, CNC plasma cutting machine, then submerged arc welding machine, then metal inert gas welding machine, beam rotating machine, etc. So these are all other equipments which had to be incorporated in the process. Now regarding the components of the span truss, you'll see that it comprises of top chord members, bottom chord members, diagonal members, vertical members, top chord members, again bottom cross girders, bottom cross pressings, bottom cross joints, top joints, stringers, and stringer cross pressings. So this is fabrication of component. The first one is the top chord and bottom chord members are box sections with box dimension of 1 meter by 1.5 meter. And total contribution of this box into the entire assembly is about 21%. Then diagonals and vertical members are also box sections with box dimension of 1.1 meter by 1 meter, and they accounted for 11% of the total tonnage. Then top floor members, these were all I sections, and they accounted for about 9% of the total weight. Then further is bottom cross girders, and also these are also box sections, and they accounted for about 14% of the total weight. Then fabrication of the component, stringer beams are built to I sections with bracings connected by HSFG bolts. The stringer beams are connected to bottom cross girders by stainless steel bolts, and it accounted for about 15%. So we had developed a fabrication workshop just near to the site. So before I go into this, I must tell you some background of this. Initially, when the project was awarded to SSC, the planning was that work will be continued from 2 different banks of the river. That is from the north bank and from the south bank. And that would require us handling of 5 trusses at a time through 1 train, which would require us to handle about 8,500 MT of steel materials. But then when we had taken the recce after award of work, we have seen that these 2 banks are so distantly connected with each other that we will be required to move about 350 kilometers to reach the other bank unless we use a ferry. So that would require us to set up two independent units, and these are to be viewed as two independent projects. But then the time period was very short, so we started thinking what best can be done. So literature reviews were done, a lot of research activities were taken up, and then we could understand and we could come to know that there are some bridges in China and some bridges in Germany which have been built with handling of about more than 15,000 MT of steel. So that had given us some idea, why can't we bring that technology to India and handle, say, 10 trusses at a time, 10 spans at a time, which would require handling of 17,000 tons of steel. So our people, along with people from officers from Indian Railways and other consultants, we had gone to Germany, tried to gather informations, tried to visit the bridges which have been built with such a massive involvement of steel's requirement at a time, and the technology was transferred. And that is how ultimately it was decided that we shall be taking up the work only from one bank rather than concentrating on two banks. And that had required a massive handling of 17,000 tons of steel per train at a time. So for that, the fabrication planning had to be very robust. So we had set up two bays, bay number 1 and bay number 2, to handle all these activities. This only gives you a layout of the our fabrication workshop. You'll see that both the bays have been marked. So here the activities basically receipt of raw steel, followed by cutting section, then followed by box fabrication, followed by joint section fabrication, then grid blasting, painting, and then shop priming, after which the materials were made ready as a finished product, ready for transportation and to be placed at site. So regarding fabrication planning, you'll see that in Bay 1 we handled about 26,305 MT of steel materials, which accounted for 45% of the total requirement, while in Bay 2 we have handled about 32,456, so totaling about 58,000 MT of steel, which were managed from this workshop. So this is a flowchart of fabrication which is known to each and everyone. This is a standard process. We did not do anything special in this. So fabrication process is basically receipt of plates, then making the components, then making the modules, and these modules are assembled together to form the truss. That is how the system was continued. And this is a view of a typical component. You can see it comprises of a bottom girder, then top chord, bottom chord, top joint, diagonals. That's all. Next. So this is a view of the fabrication yard for cords and joint fabrication bay. Then fabrication plate cutting activities were going on, and CNC plasma cutting machines were deployed, and CNC oxyfuel multi-torch cutting machines were also used. Then fabrication, the edge preparation was done by scalloping and by beveling. And then types of welding was carried out in following methods. One is GMAW, that is gas metal arc welding, and another is fabrication submerged arc welding. And fabrication was carried out maintaining the following sequence: fit up, welding, then assembling. This is a view of submerged arc welding that was being done, and box cutting machine. So fabrication, this is a typical procedure that we have followed during fabrication process. Non-destructive tests were carried out to ascertain that the welding that has been done is up to the mark and is meeting the specification without leaving any gaps or cracks into it, which might create problem during the maintenance period as well as during the assembling period. These are certain photographs showing you the top chord, bottom cross girder, top chord, and diagonals. The planning for the workstation is, you may see top chord, top joints, bottom joint, bottom end joint, top end joint, diagonals, verticals, etc. The fabrication time that was allotted to fabrication of each of these components was minimum of 34 days, maximum of 34 days, and minimum of 15 days. And number of bed required for each and for fabrication of each and every member has been noted in this table. And we will see that maximum number of beds were allotted for fabrication of top chord and bottom chords. You may skip this. So this is a view of the fit up and welding. The corrosion protection system, as I said, this area falls in the severe corrosion zone, which requires that proper corrosion protection system has to be applied. So there are about 7 numbers of different processes that have to be applied in order to make it anti-corrosive, so that the design life can be assured. And as a matter of fact, the project has been running, and this corrosion damages have been observed also and measured also, and it has been found very, very satisfactory. Then proposed method of assembling is that it required basically 39 number of spans with 125 meter and 2 numbers of abutment spans with 32.6 meter, and weight of normal truss, that is of 125 meter, was about 1750 MT, and net period available for assembling was 24 months, so which in other words means the required rate of assembling was 2 truss per month. So that was a horrendous task, Herculean task, but with the help of everyone, we could come up to the expectation of Indian Railways. Then assembly of truss spans, assembly into the full span length with correct precamber. This gives you a view of this. And proposed method of assembling, which was actually followed at site, it was composed of 5 different parts, and these parts have been shown in different colors. Next. So here are some of the photographs which were taken during execution of this project. Next. Now, methodology of launching, as I said, that was the most daring challenge for us, that how to handle this 17,000 of MT of steel at a time in a train comprising of 10 different trusses. So launching was carried out in four launching segments, truss trains. First 3 segments consist of 10 125 meter spans, while the fourth one consists of 9 125 meter span. The first and the last spans of launching segment are end spans, while the remaining spans are normal spans. Launching system consists of nose and tail to counter the maximum cantilever condition while launching. Then position of pulling devices at pier number 1, pier number 11, pier number 21 and 31, and pier number 40 with capacity of 2 numbers of 400-ton hydraulic jacks. 2 end spans were also required. So this is the launching sequence. You'll see the first sequence is of 10 spans with 125 meter length, again 10 spans of 125 meter length, and 10 spans followed by 9 spans, which I have said in my first slide. So these are the views which were taken, photographs taken during the launching operation. So this is general arrangement of the deck slab. The deck slab construction procedure, the following were actually done. Slabs were divided into 2 parts, vertically, bottom portion precast and top portion cast in situ. This proposal was based on guidelines for partial precasting by PCI Bridge Design Manual BS 5400 and BS 8100. Then precast slab of size 9.6 meter by 2.7 meter in central zone and 1.295 meter by 2.7 meter in cantilever zone. In situ portion of deck slab consists of concrete at top of cross girder and concrete on top of top chord members along with top 125 mm portion of deck slab. 125 mm was tentative size. We are considering this can be based on the design requirements, but ultimately this is the one that was followed during construction also. Then on the concreting activity, some photographs, those were taken during the time, are placed here for your view. Then H-beam slipper fixing of lower spans. Now Bogibeel project key time cycles for each span, you'll see from this slide that basically the fabrication activity, it took about 60 days time, followed by another 40 days time for galvanization and other anti-corrosion measures application. And assembly, it took about 50 days. But for launching, which we were afraid of, that which might be taking a lot of time, but then this work could be completed in a pretty small period of time, that is in 3 days and 7 days of lowering. So in 10 days, practically, we could lower and made it ready. So other major technical aspects of the bridge are bridge inspection trolley. As I said, 2 numbers of trolleys on either side of the bridge for regular inspection and maintenance of the bridge have been provided. And this is for the first time that such an arrangement has been given in any of the road bridges in the country. Then spherical bearings, total about 164 numbers of spherical bearings were imported from abroad, and these are of the capacity of 29,000 kilonewton of 120 for the 125 meter span and 8,400 kilonewton for the end spans. Before commissioning of the bridge and bearings, load test was conducted at the only capable test facility in the world at Tonga, Shanghai. This project was inaugurated by the Honorable Prime Minister of India, Sri Narendra Modi ji, on 25th of December and dedicated it to the nation. And since then, the bridge has been serving enormously, meeting the expectations of the people. And the support extended by the Indian Railways and dedicated effort of the officers and staff helped immensely in completing this challenging task. The key advantages, this has already been told in the first video that has been run, wherein it was mentioned that the travel distance between Assam and Arunachal Pradesh has been reduced by 150 kilometers, and the bridge is of strategic importance in the sense that ease of mobility between to Indo-China border near Tibet in Arunachal Pradesh has been made very easy, which is was a matter of strategic importance, that materials, arms, ammunition and other things can be carried very easily, which otherwise would have required 18 hours of additional journey from the banks of Assam. So with this, I conclude this presentation. With me, my sector head, Mr. Rajiv Sureka, is available, who has been involved in this project right from conception to commissioning. And Mr. Srinivas Gowda, who is the project manager for the ongoing project here in NH34, that is Parampur Farakka Toll Works.